and welcome back to AP Chemistry. You're here with Mrs. Mays. We're going to work on naming compounds. First of all, when we're writing the formula of a compound, that formula needs to result in a complete valence shell for every atom in that compound. Atoms must gain, lose, or share electrons in order to complete the octet. The only exceptions to these are atoms that are beyond the third energy level because they can have more than 8. So knowing the number of valence electrons of an element allows you to determine the formula of its compounds. For instance, what compound might form from carbon and sulfur? Our first step is to write the charges. Carbon can be a +4 or a -4, but if it's going to hang out with sulfur, which is a -2, then carbon has to be the opposite charge. Then we'll crisscross the formulas. Then we crisscross the charges. See how the 4 drops down and the 2 comes across? Leave off positive and negative because it's just the numbers that crisscross. And then you may have to simplify the formula because both of those numbers are divisible by 2. I'm going to divide both by 2 and it simplifies to CS2. So here's a couple more examples. Aluminum has a 3+ charge. Bromine has a -1 charge. So let's crisscross. I need 1 aluminum to hang out with 3 bromines. So my formula becomes AlBr3. Next we have potassium, which is +1, and the sulfur is a -2. So we'll cross the charge down, 2 potassiums, and then this charge comes down and across, 1 sulfur. Now if you have 1 of something, you don't have to write the 1 in. It's given, so you can just leave that part out. K2S is fine. Lastly, we have zinc and oxygen. Zinc is a 2+, oxygen is a 2-. So now when I crisscross the charges, I'll get a 2 on both of these. Well, that's not okay because that's not in its simplest form. So now I have to reduce the terms, divide both by 2, and it's just ZNO. Now most of you guys are on top of this already. You know a +2 and a -2, they just cancel, so that formula is ZNO. But now it's your turn. These are the ones that you get to try. So pause the video and work these out on your own. I will be checking in class to see what you got. Now let's look at naming ionic compounds. For writing the names, we just have to change the ending to IDE. So the second word gets its ending changed, like sodium and chlorine becomes sodium chloride. We always have the cation written first. So it's not chlorine sodide. That sounds silly, doesn't it? It's sodium chloride. The positive charged particle comes first. And we don't capitalize names of substances unless we're starting a sentence. Give the formulas and names for 3 compounds. Let's do 3 and then I'll let you do 3. So if calcium's a 2+ and iodine is a -1, then this formula looks like, crisscross your charges, CaI2, and its name, we name the first cation, calcium, and then we name the anion and change the ending from iodine to iodide. Next is O plus Mg. So I have the 2- charge and a 2+ charge. Since they're the same, they're going to cancel each other out. But look, I'm going to put the positive charge first. We always write the cation before the anion. And now let's name it. Name the cation magnesium, and the anion is oxygen. Change that ending to IDE and we're all set. Sodium has a +1 charge, sulfur has a -2. So let's write this formula, crisscross the charges, so I get Na2S, and we'll name this sodium, and then sulfur becomes sulfide. It's really just that easy. Don't make this harder than it needs to be. Now let's look at naming compounds that have multivalent metals. So the name's still going to end in "-ide", the cation still comes first, but these metals have more than one charge. So the name is going to have its Latin root, and then it will end in ic or us to denote which charge we're talking about. So copper is going to be cuprum, and a +1 is cuprous, the +2 is cupric. The lower charge gets OUS, the higher charge gets to be ic. So let's give formulas and names for these ones. So the 2+ form of copper is the higher of the two charges, because 2 is higher than 1. So we'll call this cupric chloride. So the same way as before, only now we have to decide which kind of copper this is. Cobalt comes in two forms, 2+ or a 3+. Since the 2 is the lower, then I use the OUS. This is cobaltous chloride. We can't just call it cobalt chloride. That's just not specific enough. There's two types of cobalt chloride. So remember, ic is higher than us because I am more important than you. I'm not. That's just the saying to help us remember. Okay, so if we have multiple valence and we want to use IUPAC naming, what I just showed you is called classical naming because it uses the Latin root. But IUPAC naming is the international system that all chemists use. So the process is the same. The name ends in IDE, the cation comes first, but this time we're going to use Roman numerals instead of Latin roots. So copper 1 is indicated with the 1 in parentheses, and the 2+ form of copper has a Roman numeral 2 in parentheses. The numbers, be careful, the numbers refer to charge, not to the number of atoms. I see this mistake a lot in beginning chemists, that they want to put copper 2 just because there's 2 coppers there. So look at the charge and decide what it is. That's a 2+ charge, so we call this, instead of cupric chloride, same compound, is going to be copper 2 chloride. That number tells us the charge. And then Zn2+ and Cl, you might want to call this zinc 2, right? Zinc 2 chloride. But I was tricking you. Zinc only has one kind of charge. It's at the very end of that d orbital, so it's only ever going to lose 2 electrons. So we just call it zinc chloride. You see, the multiple valence indicates there's more than one charge. If there's not more than one charge, don't put parentheses behind it. Silver is always +1. Zinc is always +2. So we don't use parentheses for those. Aluminum is always +3. So we don't need parentheses, it would be redundant. Okay, now it's your turn. Give these ones a try. Oh, but with mercury, be super careful. I want you to do both kinds. There's mercury 1, that is diatomic. That's mercury 1. And then this is the formula for mercury 2, which is monatomic. So be careful. I'll be checking in class to see how you did with those. Now suppose that you have a compound with a polyatomic ion. These are just groups of atoms that interact as a single unit. So this -1 charge belongs to the oxygen and the hydrogen all at the same time. That means there's an extra electron zipping around the whole structure. The sulfate ion carries 2 extra electrons, and they zip around, giving it all a 2- charge. And then there's phosphate that has 3 extra electrons embedded in the structure. And they create an octet. When we add extra electrons, it stabilizes the entire unit, so they can interact with other atoms or other molecules as a group, and they don't split apart. These tend to form, these always form, ionic compounds, because they're called polyatomic. There it is, ions. Who knew, right? Ions would form ionic compounds? It's true. They do. So first name the cation, then name the anion, and then you're done. It's that easy. So here we have Ca for calcium, and then OH is called hydroxide. So I name each piece, and I'm done. Calcium hydroxide. Boom. Now, this one's a little trickier. Since sulfate has a 2- charge, we know that this kind of copper is the kind that's a 2+ charge, not a +1 charge. So let's name this copper 2 sulfate, not just copper sulfate. That would be inadequate. There we go. Okay, your turn. You're up. You have two of these to try. Ready, set, go. Oh, well, push pause, then try. All right, let's look at covalent compounds, which is what we get when a non-metal is interacting with another non-metal. They'll all end in IDE, and each element gets to have a prefix. That prefix tells us how many atoms of each element is going to be there. How many atoms. Does not tell us the charge, it's just telling how many atoms. So 2 is di, so I have a prefix, meaning it goes before. Dinitrogen, and then I have to end in "ide," but I have a prefix for my oxygen to tell how many of those there are. This is tetroxide, and if I have 2 vowels together, I'm going to drop the first vowel. There it is. If you have a combination of AO or OO, drop the first vowel. You'll also drop mono for the first element. Like this element has only 1 carbon, so we don't call it monocarbon dioxide, just carbon dioxide. You can't drop mono for the second element. Like here, this is not called carbon oxide. This is carbon monoxide. Keep the mono on the second one. Oh, I think I already wrote this one out. Sure enough. So monoxide gets only 1 O, not monoxide. That would be a weird combination. So, sorry, I put that in the wrong spot. Now let's do this one. P is phosphorus, not potassium. Be careful, pay attention. And so we have 1 phosphorus and 5 chlorines. 5 is penta, so that would be pentachloride. Phosphorus pentachloride. Wow, nice writing. Okay, it's your turn. You have 3 elements to try out. Give me the name of these 3 covalent compounds. Now let's look at naming acids. This can be one of the most challenging parts. If you have a binary acid, that simply means you have hydrogen with some other nonmetal like chlorine. But if you have an oxyacid, that means there's oxygen in that acid, so a polyatomic ion is stuck to your hydrogen. Binary acids will depend on the state of the acid. If it's not aqueous, we just name it hydrogen and it's non-metal. So here we call this hydrogen chloride when it's in its gas phase. Until it bubbles through water, it's technically not an acid. If it is aqueous, then we name it as an acid. So for binary, you have to put hydro in the front, then name your nonmetal, and then put an ic at the end. So we start with hydro, the nonmetal is chlorine, so I'll use chlorine as my root, ic at the end, and then we always write the word acid after those ones. So hydrochloric acid. In these 4 examples, which ones would we name as an acid? The solid? Nope. We're just going to name that normal, hydrogen bromide. Aqueous? Yep, that's an acid. So we start with hydro, and I'm combining with iodine, so I call this iodic. And then we write the word acid. Now in hydroiodic acid, we have to keep all the vowels. Otherwise it doesn't sound right. But if you have an OO and an AO together, you can drop the first. Here's another aqueous substance that's going to be an acid, H2S. So we start with hydro, and then we take the nonmetal sulfur, add ic to the end, so we'll call it sulfuric, and then we write the word acid because it's aqueous. But H2S gas, in the gas phase, it's just hydrogen sulfide. Now, if you're naming an oxyacid with a polyatomic ion, the naming does not depend on the state. They're all acids, whether they're aqueous, solid, liquid, whatever. So we're going to replace any polyatomic ion that ends in 8 with the ending ic. Anything that ends in ite, we're going to change that ending to us. So if you could remember, I ate something icky, then you'll remember how to name acids that have polyatomic ions. Change the root if necessary for pronunciation, and add the word acid to the name of your acid. So here we have H2SO3. So sulfite is our polyatomic ion. We're going to change the ending. The ite turns to OUS, and so we name it sulfurous acid. Here's a couple more examples. NO2 is nitrite. So ite becomes OUS. That's nitrous acid. Now let's do one more. Phosphate becomes, what does an 8 do? I ate something icky. So phosphate becomes phosphoric acid. Hypochlorous acid. Now we're going backwards. This hypo isn't the same as hydro. Hypochlorous comes from hypochlorite. That looks like this. It has a -1 charge, so I know I need 1 hydrogen to balance that out. HClO makes hypochlorous acid. Carbonic acid doesn't have any prefix, it's just got this ic ending. The ic came from an 8. What 8 makes carbonic acid? Must be carbonate. Carbonate is a 2- charge, so I know I need 2 hydrogens to make this balance out. H2CO3. So there's carbonic acid. So that's all you need to know about naming acids and naming compounds. We're going to practice this a lot in class. See you all soon.